Okay, we're going to get started. We're looking at the lesson 8.2, our practice problems. So yesterday we talked about experimental probability. So we're going to continue that today. All right. So use the bar graph to find the experimental probability of the event. So remember, what we're going to do is we're going to put what we want or what we're talking about for that event over what the total of all of them are. So what is the probability of rolling a number greater than 4?
2 out of 6.
So now, so since we're talking about the experimental probability, we want to look at the actual events, the results of these events. How many 5s were rolled?
7.
8. How many 6s were rolled? 1. So there were seven actual things that happened in the experiment that are the positive thing that we want. How many total are there? Well, how many 1s were rolled?
4.
How many 2s were rolled?
3.
How many 3s were rolled?
4. 6. 7. 6.
And then how many 4s were rolled?
1. 2.
So that's all together, that makes,
4.
if we add those together, 4 plus 3 plus 7 plus 2 plus 8 plus 1, that means there are 25 rolls that we did all together. So this is what we want for that experimental probability. And then what is 7 divided by 25? That is 0.28, which changes to 28%.
How do we get 7?
Because that is at 7.
So we're only doing the rolling a number. And there one that has 8.
All right, so on this one, it is 7 out of 25.
Yeah, but why wouldn't we?
That's a good point. There are, how many of them are there that are greater than 4?
2.
No? 9. So you're right. This should actually be 9.
Wow.
No, I did it wrong on purpose, so to see if anyone would catch my mistake.
So I did it?
Good job. So this should actually be 9 because we're talking about the experimental and not like the theoretical. So by the experiment, there were actually 9 things that were rolled that were bigger than a 4. So let's redo our calculation.
Wow.
So that changes it to 36%. 36%. Okay? So then I want you to try number 2 and 3 on your own in a minute. We're going to go ahead and talk about the rest of these problems. You don't have to do number 4. Okay? On number 5, however, there are 4 broken eggs out of a shipment of 600. If another shipment of 3,300 eggs, how many would be expected to be broken? So we're going to make a fraction. 4 out of 600 were broken. What does that reduce to? So 4 out of 600, that reduces, and I'm going to change this, hit the toggle button. That is 1 out of 150 that were broken. So what we're going to do then is we're going to set up a proportion. Open the door. And so that's going to be 3,300. So notice how we set up the proportion. We took the fraction, right? Okay, stop talking. So notice again, what did we do?
I don't know.
We put 1 over 150, right? 150 being the total. So then we're going to, out of 3,300, how many will be broken? So we're going to cross multiply. 150 times x is 150x. And then 1 times 3,300 is 3,300. And then you're going to finish that part on your own. Remember, at the end,
Mr. West.
you have to include the word eggs in your answer.
Oh. Oh, never mind. I figured it out.
Okay. Now, you don't have to do number 7.
What do we do after that? After the 50
If you have 150 times x, what do?
You multiply.
divide. Can you get my calculator?
Okay. Now, on number 6, 2 coins were flipped 16 times each. 2 heads landed 3 times. 1 head and 1 tail landed 11 times. And 2 tails landed 2 times. Okay, so we had several results. We had 2 heads. We had 1 head and 1 tail.
Do we not do 7?
And then we have 2 tails.
Why does yours look different than ours?
Wait, will we have to put number 5? Will we have to put the answers like 22?
Now,
Equal or x equals 22.
eggs.
Oh.
So on this one, let me redo that line. We have 2 categories here. We have the we have the theoretical, and then we have the experimental. Can you stop doing that? I know who it is. All right, now, what is the theoretical probability of getting like an event where there's 2 heads? Okay, so there are actually 3 things that could happen, but one of them could happen 2 different ways, right? So we could get 2 heads. There's only, right? Both of them would be heads. But if we talk about the 1 head and the 1 tail, we could have the first one's a head and the second one's a tail, or we could have the first one a tail and the second one a head. There's actually 2 ways to get the second result. 1 head, 1 tail, or 1 tail, 1 head. Yeah. So there are actually 4 different things that could happen, right? You could get 2 heads, 1 head, 1 tail, 1 tail, 1 head, or 2 tails. Anyway, you understand what I'm saying? So there are 4 different results that could happen, but the 2 heads is only 1 out of 4. That is 25%. To get a head and a tail, there's actually 2 possible ways out of the 4 to get that.
So it's 50-50?
And then the 2 tails would be back to 1/4. Now, if we talk about the experimental, if we talk about the 2 heads were landed 3 times. How many times did they do this? 16. So the 2 heads experimentally was 3 out of 16, which is going to be 3 over 16. That is 18.75%. 18.75%. I know. All right, so then you're going to do the other 2 on your own, but we have to use that information to do number 8. So on number 8 kind of is a combination of what we did on number 5 using our results from number 6. So on this one, based on the experimental probability, how many times would you expect each outcome to land if there were 240 trials? So let's say we talk about the 2 heads first. All right, so my experimental with the 2 heads was 3 out of 16. So to set this up, we want to know how many times do we get 2 heads if we did it 240 times. You with me?
What?
With you, sure.
So we take the experimental fraction and put it equal to x over 240. Why 240?
You cross multiply.
Then we cross multiply. All right, so then we do 16 times x, which is 16x. And then 3 times 240.
720.
3 times 240 is, in fact, 720.
Wow.
And then we'll divide by 16.
45.
And when you divide by 16, you get 45. Now, in the Chromebook, it's going to want you to have 45 times. Okay. Now, that's just the first choice.
So we have to
You
put X
you
equals-
then have to do just the 45 times. You then have to do the one head, one tail, and the two tails. So you have to do number 6 and then use those results to do number 8.
I don't like you.
You know, my dad used to say,
Oh my god. Do anything you don't like.
Yeah,
that's not even close to what he said.
Sometimes you have to do stuff you don't want to.
Thank you. My dad would be so proud.
Same outcome.
Mr. West. I hope my day keeps going good.
Good. Okay. Turn the paper over, and we're going to talk about this, and then I'll give you some time to work. A bag contains the letters shown, right? Outcomes. So we got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 altogether, 8 tiles altogether. Okay. You randomly draw a tile, record it, and then return it to the bag. The bar graph shows the results of drawing a letter 50 times. Compare the theoretical and experimental probabilities of the event. Okay, what is the theoretical probability of drawing out an S?
5 times.
How many S's are in the bag?
1.
1. So 1 out of how many tiles?
8.
8 tiles. There's only one chance of doing that. So 1 divided by 8 is 12.5%. Now, let's look at our results. How many as our experiment, how many 5 S's did we get? We got 5 of them. And how many times did we draw out of the bag? 50 times. So if we go to our calculator, 5 divided by 50 is 0.1. That is 10%. Because you got to move the decimal 2 places. Okay. Then there's going to be a question that it's going to ask you. It's going to say,
Mr. West.
is that, let me finish. Is that, it's going to ask you right here. The experimental probability is, do you think it's close or not close?
Close.
It's close to the theoretical. Correct. 12.5% and 10% are relatively close. Okay?
Oh, never mind. I figured it out. I thought you were just choosing a small one. It says 7S, so that's why you did it. Never mind.
Okay. Now let's look at drawing. I'll do one more with you, either number 10 or number 12.
11. Which ones are vowels?
Do you want me to do the one with the vowel or the one that says not a C?
It's vowel.
Blue vowel.
All right. So a vowel is A, E, I, O, or U, right?
Or Y.
There's no Y's in this one, though. Okay. So if we think about the theoretical, how many vowels are in the bag?
One.
There's O, a U, another O, and an E. Yes. I know, but I'm making a recording, so I need to actually say the things.
Please don't. cut
I don't
that
think
out.
it can record you guys way over there.
Don't
So
cut
this
that.
this is there's 4 vowels in the bag. How many tiles are in the bag?
Or
8. There's 8 in the bag altogether. So what is that as a percent? 50%. Okay, 50%. Now, the experimental, okay, so we know it's going to be out of 50 because they drew 50 times, right? So how many vowels are in when they did the experiment, how many vowels did they get? So E was 6 times, O was 10 times, and the U was 8 times. Why'd they get the most? Why did they get O the most?
Because there's 2.
There's 2 O's in the bag. Okay, so if we add the vowels up, right, the 6,
16,
the
11,
10,
21.
and the 8, right, that is 24 vowels were drawn. Okay, so then we're going to go 24 divided by 50, and that is going to be 48%. So is that close or not close? That's also close. Okay, so I want you to try the other ones.
What would not close be as that?
Probably more than 5%.
what is not drawing a C to me?
You draw everything else except
Other
a
than
C.
So it's 7 out
Just
of 8.
think about it for a minute. Think about it for a
7
minute.
out of 8.
Okay, now on 13 and 14, this is what I want you to do.
My calculator froze.
Yes. Oh.
All right, that's all I have to say about that. Hold on just a minute. Hold on. So on the online, you're going to have to answer these, and then on number 6, number 6, there's room for you to do both of those there, and then same thing on number 8. You have to do all 3 of those. I'm just wanting, so each of these says times. Like this was 45 times. Okay. And then on page 2, you have to answer those questions. And I think that's it. You're going to do great. You got 30 minutes. Isn't that awesome?